Hello, everybody, and welcome to the July meeting of the Howard Astronomical League. I thought I had it together. Now I don't. Here we go. So welcome to the July monthly meeting of the Howard Astronomical League. We've got a pretty interesting meeting tonight, kind of geared towards a little bit towards beginners, but I think people who are well steeped in the hobby will find it interesting too. And kind of a theme tonight on visual astronomy. The club, we have a lot of, as you'll see at the end, we've got a lot of very high level astrophotographers in the club, and as well as many beginners too. And we spend a lot of time doing astrophotography and talking about astrophotography. So tonight will be a little bit different. So is there anybody new that would like to, you don't have to if you're shy, but if anybody want to say hello or introduce themselves, we got a new member?
Hello, everyone. My name is Ian C. I live way over in Rockville. I am just looking around at astronomy clubs. I've been kind of going solo with the astronomy hobby since I was 10 years old. I am an avid astrophotographer. I've got 2 telescopes out in New Mexico, remote observatories. I have a few telescopes here in Maryland, everything from this monster of a 24-inch Dobsonian, which just is getting too big to do anything with other than hang stuff on, and a couple smaller telescopes. But I'd love to get back into visual observing because I've been doing astrophotography remotely for so long. It's really turning me more into a software specialist than a sort of avid astronomer where I started. So just hoping to connect with people.
That's fantastic. Ian.
Right.
Yeah,
Where do you do
welcome.
your observing?
Hmm?
Where do you do your observing?
So there's a place called Deep Sky West, which is a shared observatory. You lease space on a pier. They give you electricity and internet connectivity. And, tech service that might take a week to get there because it's pretty remote. And then everything's just downloaded from the internet.
Well, great, welcome, and I hope that the club will you'll find it useful, and I think a lot of myself, I hope to see you at some events because I'm sure I can learn and learn something from you as well. We're going to talk about a remote setup, a potential remote setup for the club later, so that could be a very useful conversation we have. Yes.
I'm a rising senior, not high school. This is my first time here at home. I was teaching astronomy when I was little for a long time. I've since switched to medicine, but I saw this online and I saw that they were going to be talking about ophthalmology today, so I thought it'd be interesting.
Fantastic. Welcome. I have a daughter who's a rising senior at Mount Hebron. Oh, and Papa.
I'm just combining the.
Great. Welcome.
It's good. It's first time for me. I'm sure I'm gonna learn something.
Great. She can rely on you to buy her the things that she needs.
Yeah, my name is Marvin Simmons. I've been a member for at least a couple of years. This is the first time I've attended a meeting. I usually just kind of watch online. But on my background, I'm actually a payload controller, satellite engineer. I've been doing that for like 15 years. Actually more than 15 years. And that's just tracking spacecraft. The spacecraft that take the pictures of the planet. I'm one of those guys in the operational center, making sure
That's
How cool is that?
maybe you can give a talk to the club sometime.
Unfortunately, I'm unemployed. I am looking for work, so
Open for work.
that's that around. But yeah, I've been an avid Cosmos guy for a long time.
Great.
The pictures that they send back, especially now that we got web up there taking pictures, is sending out some awesome stuff.
Cool.
Yeah, good to
Welcome.
be here.
I think when longtime members come to their first, we ought to have like a little candle on a little cake to present. Hi, Ken, welcome. Anybody else?
Well, my name is Tommy Dowell. I'm been a member for a while, but I've been coming so sporadically that every time I come, it feels like the first time. I'm retired Naval Electronics Chief. I did heavy terminal SATCOM, air traffic control radar, all that stuff. And I've been in astronomy for a long time, and I'm just right now totally enamored with Webb.
Oh, yeah,
What's the whole finding on what the universe we thought it was.
well, great, welcome to the club, and I think this will be a good meeting for you folks that are new, because we're gonna talk about some new stuff. And I want to talk to you afterwards, because my daughter is, you may know my daughter, Sophie Sanchez. Okay. Okay, so we'll go ahead and move on to the next part of the meeting. We have some announcements. So we like to talk about our star parties and what's going on. We have some, once a month, if you're new, you may or may not know this. We have a members only star party where people come out with their telescopes and do their own thing, and sometimes, get nerdy and share information with everybody. And then we have a public star party once a month as well, where we tend to break out our telescopes and allow just members from the general public to come out. So the next two of those are coming up on the 26th of July with Jared Case as a host. And then on August 2nd, we have Jose Urias, Ken Everhart, who just walked in, and Krystal Rolan, who is also our librarian, our excellent librarian. Other things that just happened, we had a couple of impromptu star parties since the last meeting, but we finally had our first not rained out public star party on the 5th of July. And it went pretty well. We had about 15 people set up their individual scopes. We had the observatory with the scope inside doing its thing. Krystal, I think, counted over 200 people that, came and went over the course of the night. People were looking at all sorts of the regular summer deep sky events.
We had a conversation whether we should keep it on the 5th of July or move it because of the holiday weekend. And Krystal was about 200, but it was sparse. It wasn't like there was ever long lines, which that night would have usually been well over 300 with a night like that. And so maybe if we fall on a holiday weekend again, we should take that into consideration.
Yeah, you should start coming to the planning meetings again, so you can tell us about that. Yeah, I'll mention that to David. David usually does the planning. Another thing, Krystal had her activities table, her tent set up with, and I heard lots of kids giggling and doing their activities in there, some kind of solar sail project. Arjun was manning the solar system table. So it was the regular crowd, and it was a nice party. The one thing that was different was that we actually had Maryland Public Television present with 4 people, a drone and some cameras and audio booms, and they're doing a show on dark skies in Maryland. And so they did some filming and interviewing of some of our members. So we will, if they mention when that show's going to be on, I will pass it on to the club so we can all have our 15 minutes of fame. Couple of things that are coming up it's not really in the immediate future, but in addition to our regular star parties, we have a star party on the 29th at the Howard County Nature Conservancy on Route 99, not too far from Alpha Ridge. And a lot of their members will be there. It'll be a good opportunity to share views with a new crowd. And also to, fulfill our club's joint obligations with Conservancy, because they let us use their grounds on occasion when there's things like comets low. They have a really good low western horizon view. So, and then also it's really early for this, but in Washington DC, on the Mall, this year, the Astronomy Festival on the Mall falls on the 20th, and the club will be looking, I'll be there with my telescope and we'll have a table. But it's a good opportunity to meet a lot of people and talk about the club and meet other clubs as well as professionals in the industry. I got people to come and give us presentations from people that I met there last year. It's a kind of a fun event.
20th of what, this month?
20th of September.
September.
Yeah,
Is that in the daytime or the evening?
it's in the evening. Though it actually goes, it starts in the late afternoon. Last year it was in the middle of this, it was like they held it on the longest day of the year, so there was a lot of solar scopes out there and it was super hot. So this year they decided to make it a little different. So it'll go in the afternoon. There'll be activities and tables set up, and then it'll go until I don't know when, 10 o'clock or whenever they shut it down. I had a line of people they were trying to shut it down. I had a line of 15 or 20 people trying to look through my scope at M13. Even in the light pollution of DC, you could still see it. Okay, so anyways, those are things that are coming up. I will definitely reach out and ask for volunteers if people want to come down again as we got closer to the dates. So next on our agenda is Book of the Month.
All right, so hello everyone. Today's book I'm really excited about. So this book of the month is Bright Galaxies, Dark Matter, and Beyond: The Life of Astronomer Vera Rubin by Ashley Jean Yeager, published in 2021 by the MIT Press. This book offers a really excellent blend of her personal life story with also the evolution of science and astronomy kind of happening in the background of her lifetime, and especially how her contributions played a role. So we know that there are particles and forces that we do not fully understand, undetectable by traditional means, that are integral components of our universe. And Vera Rubin played a pivotal role in convincing the scientific community that there were unexpected behaviors in galaxies. So many of you are, if you are familiar with her, may know about her galaxy rotation curves, and that contribution led to the eventual acceptance of dark matter as serious astronomy. While there were discussions of the possibility of dark matter in the earlier parts of the 20th century, those ideas were only able to gain that sufficient traction in the scientific community through the hard work of many astronomers, including Vera Rubin. And her contributions in particular were incredible, considering the barriers of the widespread sexism at the time, her limited access to telescopes. So a lot of our largest telescopes in the country did not allow women observers to use them, even if they did have like a PhD. The dismissal of her work by journals and mentors delayed a lot of her contributions early in her career. And I really, in particular, love her story because she adamantly kept asking questions without making assumptions. It's easy to say, oh, that's an outlier in the data, or that's unusual, we'll fix it later, but really her gift was asking more questions. She did receive a National Medal of Science in 1993, but she never the Nobel Prize. Many have argued that she was absolutely a worthy candidate of it, but perhaps overlooked because of her gender. She's since been memorialized with a ridge on Mars, an asteroid, a galaxy, and most recently, the Vera C. Rubin Observatory, the first national observatory named after a woman. I highly recommend this book. It really weaves beautifully her observational work into the grander story of dark matter and the impact that it's had on astronomy as a whole. So,
Thank
look at
you. And thanks for excellent timing on choosing that book, because it's been less than a month since Vera Rubin's been operational, hasn't it? So thank you. Chris, you want to talk to this?
All right, so as often happens, club members donate equipment to HAL from time to time. And recently, a longtime club member by the name of Benny Palmer, some of you might know, donated this telescope rig to HAL. I've got the list of everything that's included here, but this was basically an astro-imaging rig that he would wheel. It doesn't show it in the picture on the left, but that tripod has wheels. And so he would wheel this out on his back deck to do astrophotography. Next slide. The question the board is struggling with is, what should we do with this scope? Some of the options that we've discussed are, obviously we can either sell it or auction it, either piecemeal or as a whole package. There are advantages and disadvantages to each of those approaches. We could use it for public outreach in much the same way that we currently use occasionally the Meade 16-inch. As I mentioned, it has wheels. It fits in our storage shed right next to the Meade. And so it could potentially be wheeled out, though being configured for astrophotography with an ASI Air, we would need to have some sort of display, an iPad or something similar. And then the third option, which is based on my experience with Starfront observatories, and I think our new member Ian does remote astrophotography from a similar facility, is that we could potentially send this rig to Starfront observatories and have that astrophotography rig hosted there for the use of HAL members to do astrophotography. Note that that would cost $300 a month, and we'll probably incur some additional expenses involved in prepping that gear for Starfront. Those were the ideas that have been discussed by the board. We're curious about what the membership thinks. Not a discussion that we want to open up to the floor like right this minute, but I'll be sending out an email to the HAL mailing list either later tonight or tomorrow to start that discussion. And we'd be interested in whether or not any HAL members have additional thoughts or ideas, or whether or not having an astrophotography rig hosted in the middle of Texas in Bortle 1 skies would be something that HAL members would be interested in using. So I think that's all I have, Victor.
Thanks. That's well said and well put. And should we, I guess we can talk about this offline, but maybe we can send out a survey monkey or one of those things to get feedback from the membership.
Yeah, we didn't have time prior to this to make arrangements for like a website poll or anything formal. So I figured we'd probably just stick it to the mailing list. But yeah, maybe we can chat on the leaders mailing list after this meeting as to the best way to solicit feedback from the membership.
Yeah, so club members, it's your club. We're kind of at the helm right now, but you know, if anybody's interested, every year we hold elections. If somebody's excited about getting involved in the club, by all means, we'll be talking about this in the next few months about how you can join the board, become a member of the, fill one of the roles that the board has. But this is another great way to get involved in the club. Just, voice your opinion on what you would do. If you think you would use this, and we don't want to spend money on something that nobody's really excited about. Thank you, Chris. And by the way, that day we picked up the scope, I squirreled away, there's a solar filter too. I have it still. I put it in my car and I never gave it to you. So we need to add the solar filter to this list.
Okay, fair. Go ahead. Next time you're at the observatory, just put it in the storage shed along with all the other stuff.
Yeah, I'll talk to you about it. You're the observatory director, so I don't want to. I'll let you handle it. Okay, now we have another interesting presentation. I'm going to stop sharing my screen. And Matthew, do you want to go ahead and share your screen?
Sure. Let me get on that right there.
Yeah, and would you mind just giving a real quick introduction to like who you are and you
Sure.
and Rich, if you want, or Rich,
Yeah.
Rich, is we can hear.
Hi, Rich. Good to see you. Well, thank you, everybody. My name is Matthew Peters. I'm currently serve as the Vice President of the Alachua Astronomy Club down in Gainesville, Florida. I also help do communications down at Chiefland Astronomy Village, which is kind of a dark sky site down kind of on the nature coast in Florida. Relatively new to kind of active astronomy, as it were. I think I've only been really going at it for a couple of years now, but always had a lifelong passion for it and just sort of fell into my local club and kind of got hooked and have been doing it since. So that's a little bit about me. All
Rich,
right.
you want to say anything or?
I'm having trouble hearing him.
Okay, well, go ahead, Matthew.
Okay.
We can see your screen here.
Okay, perfect. And then everybody else can hear me?
Yeah.
Okay, perfect. All right. Well, as everybody knows, Rich was or is still a current member down at our club and kind of put us in touch. So I wanted to talk a little bit about the very small array, kind of just a little project that we have down here in the Florida area that sort of has gained a lot of interest, and we kind of want to see where it's going. So this presentation is one that I gave for my local club. So there's a little bit of stuff that I'll kind of skim through just because it's kind of fluff that you may not know. We've got a lot more entry level and novice astronomers in it. So, but astronomy kind of in the age of social media, as it were. Oftentimes, as most folks know, that it tends to be a solitary hobby. Not every night can you have a star party and get out or do outreach. So you find yourself kind of observing alone. And really in this kind of day and age, we find more of a desire to do social. I think that's why we're all in an astronomy club. New equipment and acceptance really is just kind of happened in the last couple of years. I think the entry level equipment still had a really high barrier for a lot of just the general public. So these smart telescopes that have come out have really made it super easy for just anybody, a family, a novice to come into this hobby. And then we've really kind of found that those experienced seasoned vets are really starting to understand that they're not just toys. There's a little bit more to them. So are they going to compete with a big, huge Astro rig? Absolutely not. But I don't think that's their purpose. And then social media and sharing. Everybody shares photos all the time. So you take all this time making these images, why not share them, even on some sort of lower level, as it were. So whereas, like I said, is once we showed food photos on Instagram, now astrophotographers can take astro photos and post them online. But back to the very small array, really sort of there were three primary goals for the project. It was to develop relationships between some of our clubs in our area, reaching out and just being at some star parties before Seestar came out in Dwarf and whatnot. We found that everybody kind of lived on their own little island, and you'd occasionally interact at the big star parties, but everybody would kind of go their own separate way. And it seemed kind of silly that we're all doing similar stuff. So why not interact more? And then also we wanted to bring more people into our hobby. I think everybody looks around and sees that clubs in general aren't getting any younger. So this kind of seems like a good step for bringing in the kind of the next generation of the project, but then also for everybody, just observe socially. Like there's no reason not to get together on a 3/4 moon and do projects like this. So what we ended up doing was forming the very small array. So it's very, very casual, but it is a social media organized group because the three main clubs that are involved are the Alachua Astronomy Club in Gainesville, the Chiefland Astronomy Club, which is about an hour away from us, and then further south still is the St. Petersburg Astronomy Club. So those are kind of the three main pieces. So all a couple hours away from each other. But with social media, we can speak to each other instantly. And then we also wanted to, again, observe together. So I know I heard mention that there's lots of kind of pro level imagers. So I'll kind of breeze through this real quickly, but it's basically just a little primer on imaging and that you can never have enough data. Lots of our folks don't really get the concepts of data. So we had to explain that, just these little smart devices just crave data, more data, more data, more data. More data means better pictures. So just kind of a cute little thing to talk about the dwarf. A little bit of a primer that just basically says more data over time equals better imaging. But it sounds like most of the folks in your club certainly know that. So the first instance of the VSA, we really wanted to try to test these targets. We really were looking for more faint targets. We didn't want to do the big show pieces. That's easy. We know a Seestar can do that. So we really wanted to kind of test and see what that could do. And this is just kind of an initial example of unprocessed, just straight out the can, off the app itself, frames from the Seestar group on the Thor's Head Nebula. So you can see the 10-second version, an hour and a half, which is the total amount of time that we participated in this, but just shows in the third slide what everybody together accomplished doing this all at once. So everybody individually put in an hour and a half worth of time, but that's about kind of the end result. Just a little bit of a picture. We ended up having 14 contributing members spread throughout the club. I see Guy has joined the meeting. He's we'll call him the father of the VSA, as it were. I'm sorry you're stuck with me talking. He's usually better than I am. But
Evening, everybody.
his club is really the bulk of the folks who actually participated. They're great. They're social. They observe a ton. So I want to make sure to give them credit because they really led this. So we've got a nice little group of folks that took the picture, but there were a few more folks involved. For my club, I always show them, these are the units that I always have. I always have an S50, an S30, and a Dwarf 3, just to show that, yes, we talk about the Seestar being kind of the star of the show, and that's what we found has the most market penetration, but we want to make this open to anybody who has one. If you've got a Dwarf, other people have a Dwarf, why not join it? If you've got a Vespera, whatever you got, come bring it. We want to have fun with you. So kind of all in all, we ended up having about 21 Seestar S50s, 14 of which were successful. We kind of learned that people either started it, picked the wrong target, started it, didn't save all the frames. So all the common errors of getting a bunch of people together, thinking they know what they're doing, and then finding out nobody knows what the hell's going on except for the few of us. So got 14 successful contributions of data to that, and then just kind of an aerial view of the VSA, as it were. We wanted to try to get that group shot of everybody kind of together, just to show that we did a thing. So I don't know if this is a flyover. Yeah, you don't need to see the video, but this is sort of what we did in the 2 nights. We kind of going back to it and talking about that social thing. This whole field was at Chiefland Astronomy Village, so the field itself is about 5 acres in size. But everybody here, I think there might have been a couple folks that just happened to be on the field, but 95% of the folks were here for this. So just kind of fun to see on just a random weeknight or a random weekend, you could still have a star party. So going back to night 1, we spent 2 hours on each target between the 2 nights. We wanted to do those darker targets. So Thor's helmet, magnitude 11.45. We did NGC 2903, which is an elliptical galaxy in Leo of a magnitude about 10.5. And then on night 2, we did Markarian's chain, close to magnitude of 9, and then the Needle galaxy of 10.5 as well. So when these are just some of the sort of the details, and kind of gives you an idea of the successful frames that were captured. Like I said, ideal circumstances, we don't drop frames, we don't have clouds roll through. We have everybody save their files. The numbers will get better and better. But this is just sort of what we captured with the Seestar group. In Markarian's chain, you've got about 2,800 frames that will equate to about 8 hours worth of data. This is the Needle galaxy that was captured and processed. Most of these are processed by me, so it's probably not the best reference. I've come a long way, I'd like to think, but I know if data in the hands of somebody more qualified and more capable, you might be able to eke out a little bit more data out of these. And then here's the NGC 2903. We got about 4,200 frames spread out over just under 12 hours. And then this is really what we, for whatever reason, all the data worked out, no drop frames. I think it was kind of just happenstance. And so of everybody contributing an hour and a half's worth of data, we got about 5,400 frames and about 15 hours of total data. So what Seestar takes for tons and tons of time to do, in one night, you're starting to get that outer edge of nebulosity. You're starting to get the dark shades all the way out. I personally had no idea the nebula had all this in it, because I did the same capture last season. The very first season I had my Seestar, I saw the helmet and thought, oh, that definitely makes sense, the Taurus helmet. But all this other stuff, I had no idea. But again, I'm new, so it is what it is. And then just a reminder that on the left, this is what one person captures in the night, working by themselves alone. On the right is what a group can do in the same amount of time. And then it happened to be that I had a Dwarf 3 and then Guy also had a Dwarf 3. And since we kind of knew what we were doing a little bit better than everybody else, and it's the only target that we both worked on both nights for the most part, this is what we were able to capture with on the Jellyfish Nebula using the Dwarf 3. So we got 6,600 frames, just about 18 and a half hours of data. And this is the process that I put together. And then again, just for a little tiny thing over a couple hours each night between two of us, starting to get some great nebulosity, some decent detail, again, for a scope that's no bigger than 34 millimeters. So we were pretty pleased with what they came out. So the future of the project, we intended it to be just a group, three clubs. It is what it is. But then the more people talked about it, the more interest there was. Now we're talking to people up in Maryland. So we're excited to just have different groups want to talk and join us. But that proposed some different problems of, okay, great, people want to do it, but how do we get the data all together? So we had the Facebook page, but as of really today, we haven't really even launched it with the local folks. We do have a Discord server because we heard you guys are a little bit more proficient on Discord. So we want to make sure to provide, if you hate Facebook, I hear you. It exists and a lot of people are on it, but we'll have a couple avenues for it. And then through some partnerships with the University of Florida, because we are in Gainesville, so I got to do my gator chomp. My wife, who works at the university, is over my shoulder. So if I don't chomp, she'll, oh, I'm sorry, I did it wrong.
Right,
I'll get the look. So we have an unlimited cloud server provided by the University of Florida. We still think having these remote sessions and having you guys do it and having us do it is fun. You can do it by yourself and contribute data, but we still think having a presence at some of the major star parties in our area, your area, would just kind of make it fun and kind of give life to it. And then also, again, beyond Seestar S50, any smart scope will work. ZWO and Dwarf Lab are both aware of the project and are actually supporting the project. ZWO is sending a preview S30 Pro for us to use and play with. And then Dwarf Lab actually donated a unit for us to use for funding for a website for cloud service if we weren't able to secure a partnership with UF. And then, yeah, just members from other areas. As other people are interested, we just want to open the doors to whoever wants to come and contribute data. We'll make our data available and just kind of build a community from there and see where it goes. And that's pretty much all I have.
Well, that's terrific. So I think you've just answered the question that I was going to pose, which is how do we get involved? Because there's at least 10, maybe 15 Seestars in our club, including the club owns one. So this, I think what we'll do is we'll make this available on our website in case somebody wants to just scan that in, and that's how they can get involved.
Sure. And I can send a follow-up email to you, and then if anybody has any interest, it can include my information, but it should be pretty democratic as far as who joins, how it sort of flushes out.
If somebody scans this QR code for the Discord link, say, it'll take them to the Discord page, and then what happens? They need to.
This is an invitation link, so it's set to not expire. So this is the invitation link, so it will take you to the Discord page that should say accept invitation to the very small array.
Okay, cool, terrific.
In theory, if there's problems, let me know, but I tested it and it worked for me, so.
Well, Matt, first, just want to thank you for the other night of inviting us and including us with that great discussion with David Sobel the other night. And secondly, thank you to what you're doing in Florida
and you and James Alberry, and before you, Jack Horkheimer, really being at the forefront of outreach. And this is a super idea and a great way as people are getting involved more with the digital astronomy. Thank you.
No, we appreciate it. We're happy to play our part. Like I said, I'm a new guy, so I'm just kind of joining in and trying to do what I can, but it's fun to be involved.
Okay, well, great. That was really interesting. Thanks for sharing that.
Yeah, thank you for
And
having us.
I'm gonna go ahead and share the screen again.
Got
Okay,
a hand up
Got a hand
on,
up. Steve.
Oh.
Stephen.
go ahead, Steve.
Quick question, where will the data be shared? I just joined both of the Discord and the Facebook.
So there is on the Facebook, we haven't posted it to there, the links for it. Discord does have the links. In each channel, you'll see a thing called VSA upload. That is a kind of the mailbox, as it were. All you're going to see from there is the inbox. So take it there. We do ask, again, it's still very new. You'll see like 4 members on it. You'll see me, Guy, I think Rich joined. You're probably number 4 because we haven't even told really anybody about it. So
SPAC doesn't know.
What's that?
SPAC doesn't know yet.
Yeah, so
It's still
yeah, it's still pretty quiet. So we want to, but there's 2 links on there. There is a request to please make sure to like use a folder when you upload, just so it says who you are, what scope you used, what you shot, just so, for organization purposes. And then on the back end of it, we take, because it's UF and they're really protective of that, and it is unlimited. We'll take the data, move it into the folder that then is available as view. You can view and download. You can't do anything beyond that, but we'll make everything available there. So anything that goes up will then move over, and then you can do what you want with it. We did divide it up into 2 different categories, that we have all the raw files, but then anybody who wants to upload their master stacks, for those who don't process, who don't know how to do it, or don't know how to do weighted batch processing and all that jazz, there'll be 2 different folders to interact with. So it's the masters and the raw files.
Matthew mentioned the monthly targets.
Yes, as part of that, with the community, we are going to set up kind of monthly targets. And while, yes, we determined July's targets, you guys can certainly be involved. It's a community. It's whoever, if somebody's particularly strong about what they want to do in August, speak up, put it in a chat, put it in Facebook, put it somewhere. And then we'll just kind of, if anything, just sort of hope to keep the train on the rails as far as, hey, let's all work on the same project, because that's where it maximizes that capability.
Okay, again, thank you so much for sharing this and for making this thing happen. It's pretty cool.
I propose that I work with Matt and we'll get a splash screen for your thing that goes across, and we can have all this.
Yeah, we'll create a website, a web page for this that we can refer people to.
I'll work with them.
Yeah, great. Okay, so moving on with our agenda, a very busy agenda. It's time for our featured speakers, and this month we have 3 HAL members that are going to talk to you. We've got, the topics are the human retina, astronomical drawing at the eyepiece, and some of the Astronomical League observing programs. We had a technical glitch on part 3 in terms of the slides, but maybe you can just get up and just talk for a minute, and then we'll have you do slides later. I hate to put you on.
Okay.
If you don't want to, we can defer it to the next, but or you can just give a quick overview of.
I could give a quickie.
Yeah. Okay. So we've got former HAL presidents, longtime members, and Steve, who's been a HAL member since 2001 and started with a little 6-inch scope and now has a big old daub out in West Virginia. So, all right, so let's just, without any further ado, I think we'll just move on. And by the way, I just want to say we have one more person. We have 21 people online and 22 or 23 in the room. So this is a first since like COVID to have this many people in the room. I'm super excited about it. Okay, Chris, go ahead, take it away.
All right. If at any point you can't hear me or there's some technical difficulty, wave your arms in the room. I can see you on the camera over here. So before I became an amateur astronomer, I spent most of the 1990s.
Just turned the video off. I literally just came in from the car and went right to the computer.
Can you put yourself on mute, please? Sorry. And Victor, I'm only seeing the Milky Way background. Okay, there we go.
they can. You know, but it would be like
Victor, you
walking into.
I'm trying to find it. There's too many, I don't have the screens.
Hey, Guy, you've got a hot
mic.
Yes, yes.
All right, I got him.
Ah, there we go. All righty. So, okay. I spent most of the 1990s studying to become a neuroscientist. As it turns out, I've spent the last 25 years as a computer geek. So that worked out great, but I did learn a lot about the biology of the eye. And so on the next slide, I want to go ahead and explain a bit about the structure of the human retina. And I want to focus on basically 3 questions. And understand these in the context of how an understanding of this biology can help make you a better visual observer. And so all the astrophotographers can go to sleep now. We'll wake you up at the end of this. Want to know, what is dark adaptation? Why do we use red flashlights? And how and why does averted vision work? So next slide.
I was trying to find the volume in the, maybe I can just turn you up on my computer.
Are you still having trouble hearing me a bit?
A little bit.
You sound good on Zoom.
All right.
Yeah.
All right. I just cranked you up over here.
Okay. But you took away my slides.
All right, I can't walk and chew bubble gum here.
We will eventually get this technology thing correct. All right, I see the basic structure of the eye.
Found it?
Yes. Can you hear me?
Yeah, sorry.
Okay, good. I don't have control of the mouse, but towards the top of the figure, you see the pupil and lens. Basically, your eye is a telescope, and the focal plane is at the bottom, and it's made up by a layer of essentially modified skin cells in a way called the retina. And it comes to a focus at the fovea, which is basically the center of your field of view. So whatever you're looking at right now, the image formed by the lens in your eye is getting focused onto the fovea. Now, the neurons that are in the retina that I'll show you on the next slide, they have axons that then run along the backside of the retina, collect at the optic disc, and then flow out of the optic nerve to the visual centers of the brain. So on the next slide, we talk about some of those cells. So the right-hand side is a micrograph of actual neurons. So they've been stained with a dye that makes the cells visible. The rods and cones are the neurons that are specialized to detect light. Rods detect, actually, let me talk about cones first. Cones are the color-related photoreceptors. They have particular photorecepting molecules in them that are sensitive to specific wavelengths that I'll talk about in just a minute. But the rods and cones are also distributed differently across the retina. What's interesting is in the diagram on the left, the light actually comes in from the bottom. So it has to pass through all these layers of cells before it even gets to the photorecepting neurons. On the next slide, so this diagram represents the transmembrane protein called rhodopsin. That's what the yellow squiggly is. The kind of teal color and the small blue and red dots on either side, that's the actual cell membrane. Those are phospholipid And the teal part is the lipid part, and the blue and red are the phospho parts. And then in the middle, towards the middle bottom, you see an orange globular, roughly U-shaped thingy. That's actually a dot. Yes, thank you, Victor. Good job. That is a molecule called 11-cis retinal. And what happens is, oh, there you go. Whoops. Yeah. Go ahead and go to the next slide.
All right, I'm trying to get fancy here.
There you go. So this is the molecule that does all of the magic, and it really is pretty amazing. Now, for those of you that know something about chemistry, this is basically a very simple isomerization, which is when 11-cis retinal gets hit by a photon, it absorbs that energy and changes the conformation. It's like the molecule twist at that one 11 to 12 molecule bond. And that's what triggers the cascade that's shown on the next slide. I'm not going to go into this in detail, but this basically shows what happens when that 11-cis retinal, and actually, Victor, can you go back 2 slides to the transmembrane? Perfect. So the thing is, proteins have some degree of flexibility. They can change shape. And what happens when the 11-cis retinal gets hit by a photon, it changes shape, which forces its protein to change shape. When the protein changes shape, that allows other enzymes and molecules to interact with the protein differently. So back 2 more slides to the cascade cartoon. And so what happens on starting from the upper left and moving to the bottom right, you start with rhodopsin, which is that protein. It gets hit by a photon, and the 11-cis retinal changes, and that changes the conformation of the protein, which then allows transducin to bind, et cetera, et cetera, et cetera. I said I wasn't going to go through it in detail, but I want you to understand that there's a whole cascade of chemical reactions that occur inside the cell, the net effect of which is that a bunch of ion channels that exist in the membrane of that photoreceptor cell, they open. And that causes a change in the potential, the voltage, in essence, across the membrane. And that, if enough of a voltage change occurs, can kick off what's called an action potential, which is basically a binary signal that shoots down the axon and tells the visual centers of the brain, hey, I saw a photon. All right, next slide. And for those of you that are still awake, if I haven't bored you to death completely, dark adaptation occurs because when a photon hits 11-cis retinal and changes its conformation and then kicks off that cascade, it doesn't revert automatically to its pre-photon state. It has to, like, work needs to occur. There are other proteins and other cascades that basically take that rhodopsin molecule that has been bleached, is the term, by the light, and transform it back into the form that can receive light. The thing is, that chemical cascade takes time. And so when you look at a bright light and then look away, you've just bleached a whole bunch of your photoreceptor rhodopsin molecules, and that part of your retina will not be as sensitive to light until all of that rhodopsin gets recycled effectively. This happens at different rates for rods and cones, and we'll get to the cone bit in a minute, but rods are the ones that we really care about because that's your kind of black and white night vision type receptors. And you can see here basically the log intensity that's shown on the y-axis here, that's related to how dim a light you can see, you can detect. And since having your vision bleached, as it were. So basically it's, you look at a bright light, you look away, how long does it take before you can detect something that's 3 micro lumens? And the answer is basically like 20 minutes. So you can see this slope, anything after about 10-15 minutes, you know, you can see some dark things again. But this is basically why, you know, you don't want white lights like parking lot lights at Alpha Ridge public star parties or members only star parties. All right, next slide.
And I suppose this is, I guess, when you, this bleaching thing, that's when you look at a bright light and then you close your eyes and look away and you still see that residual thing in your eyes. I guess that's the bleaching. That's what's waiting for the chemicals to reset.
It's a little more complicated than that. But
I thought I figured something out. Never mind. All right, next.
Yeah. So this is why we use red flashlights. Now, I've only been talking about the rods so far. And you can see here that the center of the wavelength sensitivity for a rod is at about 500 nanometers, which is in the greenish blue range. And you see that it tails off towards the red. The 3 cone photo sensors, the proteins that contain the photosensitive dyes that are sensitive to red, green, and blue differently, they have different peak sensitivities. This is part of why we can take red, green, and blue and turn it into the full spectrum. But the important thing for us as far as red flashlights is concerned is that you can see that not only is the peak of the red cone at about 564 nanometers, but even like at 600 nanometers, red is still quite bright. You're very sensitive to it and in your cones, but the rods are not very sensitive to that at all. And so the net effect is, if you were to view something illuminated by a light that emits at 600 nanometers, it's mostly only going to activate your red cones and maybe to a slightly lesser extent the green cones, but it won't photo bleach your rods, which is what you use to observe the faint fuzzies. And that's why we use a red flashlight to observe our star charts. Next slide. How am I doing on time, by the way, Victor?
Well, you're good. You only got a couple more, right?
Yeah, exactly. So the other thing to keep in mind is that rods and cones are concentrated in different parts of the retina. And specifically, and this shouldn't be terribly surprising since we see the world in color, almost all of the cones are concentrated within a very few degrees of the fovea, which is the central focus point of your telescope. As you move further away from what you're looking at on the retina, you're getting out towards the edge of your field of view, that's where the density of rods in the retina increases. And you see this little blank spot with the dashed lines that talks about the optic disc. That's where all of the axons collect on the retina, and there aren't any photoreceptors there at all. So in each of your 2 eyes, you have a blind spot in that one little part of your retina. But your brain makes up for that, and it does additive stuff that solves that problem. But you can see that the rods peak at roughly 20 degrees on either side of the fovea. So if you're looking at something roughly 20 degrees on either side, that's where your rods are in their highest concentrations, which explains why averted vision works. Instead of looking directly at a faint fuzzy, you should look one side or the other, and that will put the image of the object on the part of your retina where those rods are most densely concentrated. And so that's why averted vision works. For those of you who've never tried averted vision, that's part of your homework assignment, which I think is on the next slide. Yeah. So, is averted vision equally effective, whether you look to the left, to the right, up, or down? And if not, which direction is it most effective in? Why would averted vision be more effective in one direction than in others? And how far must you avert your eyes? And this is something that's going to vary by each person because we're all different. These are all generalized averages. And then what do those results tell you about the structure of the retina? That's all I got, Victor.
Is there an answer key to the homework, or you don't?
Yes. Go out and observe, and then, send your answers in on the mailing list.
Then talk to you at the next, okay, great.
Victor does not own an eyepiece.
I do. All right, thank you so much. Are there any questions for Chris before we move to the next speaker? Well, if you want, you can save it to the end, and we'll hopefully be done with a little bit of time. We can kibitz online or email Chris or whatever. Okay, next up we have Richard Orr. Do you want me to drive or you want to drive?
Oh, I'll let you drive.
All right.
It's like, you know what you're doing. I'm a bit of a dinosaur, and you're gonna have to forgive me for that, but I still like to draw out the eyepiece. Kind of like what you see in the silent movies, the old astronomer drawing something. That's me. This is about as complicated as I get when I go to the telescope. I have a pencil. I have a thingy that allows me to erase very carefully. And I have a piece of paper. And this is what I do. I draw on the piece of paper. I sometimes turn the paper over, take lots of notes. Then I go back and either redo the drawing by various mediums, or I will use a computer program and draw my final sketch. And you'll be seeing some of those today. But if you want to come out here, this is metal. These are the red lights, and they're magnetized. And I can turn them on, and I got two so you don't get a shadow when you're doing the drawings. Pretty simple outfit. The other thing I wanted to mention before I got started is I'm going to be mentioning this book called the Astronomical Sketching. Right now, it's probably about the best one out there, because what you'll need to do is figure out what medium you want to make your drawing in, if you want to do it. And this runs through the different types of mediums and how you draw an open cluster, or how you draw a galaxy, or how you draw the planets. All are different, and it takes a little bit of a different approach when you make the drawings. So I guess we can start with the with this. So you want to kill the lights there. Back to the first.
Oh, sorry.
Come on, you can do this.
I can do this.
It doesn't matter really what kind of telescope you use to draw in, make your drawing. The reason I sketch, and these are the scopes that I normally have been using for the last 20 plus years. my main scope that I have at the house is a large refractor. I have smaller refractors I take out in the field. I also have a 100mm binoculars, and I have an 18-inch Dobsonian, which is hidden there. And those I do most of the time. But I find that, to me, the reasons I sketch is it makes me a better observer. You see more when you're willing to do a little sketch and look back in the eyepiece and then continue to do that. You see more detail that way. Now, I'm a biologist by training, you know, and I'd come home from a hard day in the field or doing lab work, and I needed to relax. And this is how I relax. I go out under the stars and I do a drawing. And to me, it's very, very relaxing. So relaxing stress relief is probably the main reason that I do it. And it does provide a good record of the night after you're all done. What are the rules? There are no rules. I mean, it's your drawing, so who cares? You know, there isn't like you've got to use a number 2 pencil or you've got to use 4 colors and can't use any more because you got to be able to learn to blend them. This is just not true. Find out which medium works for you. I've tried all sorts through my career. I've been doing this since I was in mid-high mid-high back in Oregon, and believe me, that was 50 some odd years ago. So I've been doing all sorts of things from watercolors to computer drawings to whatever. What's most important is be comfortable when you're sketching. If you're miserable sketching, if it's hard to go from the telescope to what you're drawing, or if you have to go back to the telescope and then readjust it because it's moved out of the field of view, it makes it more difficult for you. And of course, the higher the magnification you're using in the scope, the more important it comes. It's nice to use the best scope that you got, that you're most comfortable with, and take your time. The more time you spend at your drawing, looking at the object, believe me, the more you're going to see. Okay. Oh, one more thing. Sorry, my fault. I have probably close to over 1,000 drawings on my Flickr site. I have drawings of probably, well, of all the Messier objects, all of the Herschel 400, and several hundreds more that I'm not sure where they fit in. But okay, now.
All of the Herschel 400, huh?
Huh?
All of the Herschel 400.
Oh, yeah. Well,
Wow.
don't you have to draw them to get credit for them?
I do, yeah.
Yeah. I thought,
The second 400, there's one that you can observe all 2,000 Herschel objects.
yeah, well, I'll do that
I'm not
tomorrow
gonna
night.
do that. When you have time.
So, this is a quote. My laser is not working. Like everything does in the dark. Oh, well, anyway. That's from this book. It says, why should we sketch the skies when we have such, I can't read that word. Anyway, I'll let you read as much of it as you can. But anyway, this isn't entirely true. You'll often see me at Alpha Ridge doing my sketching at my telescope, and I'll have my Seestar off to the side, taking astrophotography. So this truly isn't 100% true, but I liked it. So anyway, there is truth in this when you have big, huge rigs, which takes a lot of manpower and time and effort to get. But I'm all for you. Okay, next. And your drawings don't have to be complicated. You can start off with simple ones. Now, this is a single star, which is, happens to be a carbon star. Get it? The red one in the center. And you have, several, the field. I usually, record the size of the field, the orientation, the date, the time I took. This was a 20-minute drawing. All of my drawings I'm showing you tonight were done with a pencil and paper at the telescope, and were redrawn using Photoshop elements. All of the ones that I'm showing tonight. They may not be the best, they may not be the most sophisticated, but I wanted to keep it pretty simple for tonight. And that's a really simple way of doing your sketches. Okay. Double stars are great. To me, the winter Alberio is one of the prettiest double stars in the sky. I like it even more than the Alberio that's in Cygnus. But double stars do real well and for drawing, and again, they're reasonably simple. I usually, the field of view is given, the magnification is over there is 137, and I use the 155 refractor, which is my main drawing scope. Next. Now, some double stars are tough. This is Sirius. Can you see Sirius B off to the side there? My drawing. So anyway, okay, enough of double stars. Now, some of them are complicated. That can't get a little bit darker than that. Are you sure?
Just turn it off.
Now, yeah, that's great. Now, on a drawing like this, this takes more time. This was spent 2.5, this was around 2 hours at telescope in order to do this drawing. And then that doesn't count taking the drawing and converting it to the Photoshop elements when I do the final drawing. But you can, so this is a lot more complicated approach, and you use a different kind of approach, which I'm not going to go into, but there are techniques which helps you make sure that you can make your star positions more accurate, and how to do the smudging and the location of like a thickened area, NGC 206. But you can do galaxies too. Yeah.
I'm a little confused though. Do you start with a black piece of paper and use white?
White paper, pencil.
And
At the
then
telescope.
you invert it in Photoshop?
And then I invert it because you can take a stencil of your drawing if you want to, on a complicated one. That's usually what I'll do, and just overlay it on the computer screen, and then fill in the blanks and whatever. And like I said, I take lots of notes along with my drawings in order to get, say, the different layers of how bright and how dim, and label them or number them so I know the layers that they fit into. You learn by doing the guide is of the astronomical sketching guide is a good way to get started. They'll teach you a lot of things, most of the things you'll never use, but a lot of it is helpful. You notice here that I use 3 different eyepieces at different magnifications for making the drawing, because there are times that I wanted to give details like trying to figure out NGC 206 and M101, and to get the whole thing in a single drawing requires different magnifications, which is fair. You know, I mean, you're the one doing the drawing. Okay?
Hey, Richard, there's an online question. Jeff asks, what program is used to invert from white to black?
Oh, again, I use a Photoshop elements, and you can make it just a black screen to do your drawing on. if you take the white screen and you make a mask of it and just put it on there, then you can do that. Or another way that I used to do it was that I had a photo of a black sheet of paper, and I would put that on Photoshop Elements and then do the drawing. So there are different ways of doing this. This is Swan Bear. Does that answer the question? I guess.
I believe so.
Okay, thank you.
Thanks, Wayne.
A smaller galaxy like the Sombrero Galaxy in Virgo. It's pretty famous, but here's a drawing of it. It also shows shows Jaws. Jaws is the asterism up at the top. Yeah, right there. The three stars in a row, right there is the Jaws. There's got his backbone, and the bright star right there is its dorsal fin. It kind of goes around the galaxy waiting to chomp it. I've been watching it for 50 years, and I don't think it's gonna get any closer. Okay. Also using binoculars. I like drawing with my 100mm binoculars. This time I used 31x eyepieces in it. Here I can capture in Cassiopeia. I was able to get an NGC number, a Todd number, and a Messier object, all in the same drawing. The next, large open clusters are a challenge. There's specific things you can do to help you get the drawings. Note that in here, can you see the red giant stars, the colors? Yeah, there's several of them. So you can make the color of the stars when you do the drawing. There are several techniques in being able to put together a large open cluster, because it's very difficult to get all the stars somewhat near. And a drawing's not perfect. It's not going to be like a photograph, but you do the best that you can. That was a 3-hour drawing. Here's one of the small Sagittarius star cloud M24. And all right, 2.4 degrees. Next. Nebula are also a nice challenge. As you notice, I almost always use nebula filters when I'm doing the drawings, and I do the background stars without the filters, because the filters will pull out the stars. But you can use the two drawings, one for the nebula and one for the background stars, and just combine it into one drawing. That's what I usually do. Is there anything special about that? Most people know what the Trifid Nebula and the cluster is, the one in the center there.
Richard, can you clarify, do you make two separate drawings, one without the nebula filter and one with?
It depends. I oftentimes will do a detailed drawing on the back sheet of my paper. And on the front sheet of the paper, I will do the outline of the stars in the right position. And then I will switch over to the nebula filter, which I will do a detailed drawing on the back, but I know where it's positioned in the drawing is, and just combine them. But you could, I mean, it is your drawing, so you can pretty much experiment. Like, no hard rules, okay? A challenge from my suburban backyard in the 6-inch scope is seeing something like the Horsehead Nebula and the flame up above a nebula. Here I have to cheat a little and use a night vision device, the one by Telview, and a hydrogen alpha filter, which can bring those out even in my suburban backyard. Make a drawing. Okay. A couple of smaller globular clusters in, I believe, what's that, Sagittarius? Yeah. Yeah, and this was done at Alpha Ridge. Okay. A larger, globular cluster that was also, but is up very low in our southern horizon from Alpha Ridge. Here I had used a night, vision device in order to get, the drawing. One nice thing about drawing is that, well, one thing about photographing comets is that usually, and justifiably so, you're after the nice comet tail. And when you do that on photographs, you blow out the nucleus and you can't see the detail in it. When you're drawing, you have the option of going wide and then also of focusing in on the head of the comet. This was Neowise. I'm sure most of you remember it. This was done at Carr's Mill and with 110 millimeter refractors at 164x, which you couldn't get much of the tail in, but you can see the details within the pseudonucleus, the fountain. There's a knot coming off it and also the jets that were coming off it. And you could make out the ion trail and the dust trail. I did, yeah. When I say I use a filter, when I do my drawings, I usually do it with the filter and without the filter. Because usually whenever you use a filter, it does amplify some things, but it diminishes others. So it's kind of nice to get both views and combine them in the same drawing. Okay. A lot of people like, I guess why they asked me to come out here is because of my, I do a lot of planetary drawings. And this is Saturn. And probably done from my backyard. Doesn't say you had deck a house. And there are ways of getting Saturn correctly so you know the orientation of the rings ahead of time and have a stencil put out. You can get these online, or you can, I have a series that I downloaded and that I can just print off, and it gives me the outline of the ring, so you don't have to sit there and try to draw those rings absolutely perfect, which I'm not that talented. But once you get the outline there, you can put it in the details.
Richard, there's another question online. I think you actually did this at the beginning. Matthew asks, if not covered, can you describe your sketching setup, light, drawing, surface, etc.? I think you showed it, but online the images are really tiny. So you might need to bring it closer to the camera.
Oh, okay. Well, I can show you not what I do at the computer.
Can you see us?
Telescope.
Can you see us on camera when we're talking?
I can, because of the way I've got it set up. I can't speak for Matthew and others.
Here's the.
Now, this is very simple. Can you see it now?
Well, again, I can. Those of you online, go to the side-by-side speaker and you can make the speaker bigger and you can see what he's showing you. Okay, Matthew says he's got it.
Okay, anyway, it's just a pencil. I have an eraser template, which allows you to make small erasers. When you make errors, you will. These are two red flashlights on a metal board. And it pins down the papers, my drawing. And like that. And that's what I use at the telescope. Then you can take it home and do your additional drawings in any medium that you wish, or using the computer if you wish to do it that way.
Thank you.
Okay, now where are we? Next, Jupiter, showing Europa's shadow. I got an enlargement up above showing where the other moons were, except for Io, which was missing that day. That's a joke because Io's the closest and it's always there, but it was behind the planet. Notice, I just wanted to mention the filters that I used here. Was quite a few, but nothing compared to what the next one is. Oh, I'm wrong. This was the 1920 2020 conjunction when Jupiter and Saturn came together within half a degree. These are 3 consecutive nights that I did at the house from December 20, 21st, 22nd at about the same time. And it shows you the progression of the 2 planets next to each other. Okay. Mars is probably my favorite object, or at least it used to be. I'm getting a little old and my eyes are having some difficulty when I deal with extremely high power. I have 3 Mars drawings to kind of conclude this whole thing. Here I used 1, 2, 3, 4 different filters when doing Mars. I use different magnifications. Well, this one was done with 4.5 millimeter with Barlow at 413 power. Obviously, wait till a good night to do Mars, and you go ahead and make the drawing. Go ahead. There's another Mars drawing, which was done at the same power and same telescope and the same filters. Okay, and the last. This one was done at 530x, which is a lot of power to shove into a 6-inch scope. And that's it. Now, to me, drawing is a way of relaxing, of enjoying what you're seeing. And it also, if you want to take the time to redraw your image to make it fancy so you can show people, that's great. But probably 3/4 of my drawings never get past the pencil drawing, which I keep in big folders. Okay.
That was, any questions? Sorry, go ahead.
How many drawings have you done?
I bet you that I have at home 10,000. Well, yeah, but that's been done over 30 years, you know.
Still, that's a big number.
Yeah. You find it's best to make sure the telescope is secured into the mount.
Yeah, that helps with the drawing, doesn't it?
Okay, so thank you so much. Any questions online? Thanks for monitoring the
Nope.
chat, Wayne. Yeah, thank you. Maybe it's a blessing that we had a technical snafu, because we're kind of short on time.
Yeah,
You want
give us some other
to say anything or do it?
No, I think let's do it some other time.
Okay, so we'll save the Astronomical League observing programs discussion for another month. But it's a pretty interesting thing, and Steve is our ALCOR, our coordinator, that is the right guy to talk about it. So we'll do that. So then we'll move on to our next regular feature, which is what's going on in the sky this month. So Jim?
Alrighty. So basically, there's not a lot of planet activity. Mercury's not well placed. Venus is in the morning sky. It's a gibbous phase. Kind of cool to take a look at that if you want. Mars, really tiny, poor visual target, and even a challenging imaging target at this point. Jupiter's just beginning to get out of the solar glare and would be visible before sunrise. The only real target, and you still have to do it in the morning skies, is Saturn. And it'll come to opposition on the 21st of September. A programming note, tomorrow morning, there is one of these rare Titan shadow transits. Starts at a little after 3 a.m. The weather looks really iffy. I may get up and just kind of, and hoping against hope that it'll be there. But
oh, you get your mute button.
Go out and take a look at it. If we miss this opportunity, it'll be about another 16 days before we get another shot. Next slide.
Is this a representation of what it'll look like?
Yes, that is created by WinJupos.
So the rings are already tilted up quite a bit.
That they are somewhat open, yes, definitely.
All right.
Next slide. Of course, it's our meeting time will cover the period of August 12th, and the Perseids will be active again. It's not the greatest setup because there is going to be a gibbous moon that will interfere a little bit, but the Perseids are pretty reliable. And if it clouds out or you can't quite observe in the early morning hours of the 12th or the 13th, the night before or the night after, it could still see some decent meteors. The trick is definitely, be comfortable. You may actually need a light blanket because that time of year, I've seen it get down into the 60s or even lower. Just kind of depends. And although you don't need binoculars, they're kind of fun to have so that if you have a really bright one come through and it leaves a little smoke train, you can kind of inspect that and take a look at it. So you may want to mark that on your calendar. If you're a shooting star enthusiast, this is one of the better showers of the year. Alrighty, next. So now talking kind of like what Victor was just noting, in a couple months ago, March 23rd, Saturn reached its autumnal equinox. So basically the rings were edge on at that date. And so from now for the next 7 years, because of Saturn's tilt, it has an axial tilt just like the Earth, it's going to expose the southern side of those rings more and more. So 7 years from now, we'll see kind of like what we see here.
Jim, your audio dropped out.
Can you hear me now?
Yes.
Yes.
Okay. So the left side is what we've kind of got now. 7 years down the line, it'll be expanded. Next slide. So here's an exercise if you want to try to do this. Here's a animation that shows these rings are going to get really thin. And then after January, they're going to open up again pretty quickly. So it'll cycle through again here. Notice we start off like currently in like July. And notice, yes, they are kind of exposed, but they're closing up. So, but this is bizarre because I just said that in March, they were edge on. So why are we seeing this? Why is it that these rings are beginning to close up after they already reached their autumnal equinox? Next slide. So we have to look at some of the celestial mechanics. So consider that we are an inner planet, kind of like how Mercury and Venus are for us, if you're viewing from Saturn. And you also have to remember that the orbital plane of a planet is inclined to that of the sun. So that's the reason why we don't see a transit of Venus or Mercury every time they go through inferior conjunction. You have to be at that particular point where you're intersecting the orbit of that planet, and it is going to then also align with the sun. That's why I think it's Venus can only have transits in June, and I think it's maybe early December. It's only at those 2 points in its orbit. Okay, so as seen from Saturn, Earth is actually going to kind of bob up and down as we circle the sun. So it's a little hard to see in the diagram here, but basically the Earth is going to go above the sun or below the sun. So in Saturn's sky, if you're observing from Saturn, the declination of us, of Earth, is going to go above or below that of the sun. Okay, so that's the first kind of major concept here. Next.
I was going to guess, and I'm glad I didn't because I would have been wrong. Thanks. I was going to guess pre-session, but no, this is good.
All right, so here's a chart that kind of maps out the declination in Saturn's sky. So 0 is obviously Saturn's celestial equator. Between the two yellow lines are from starting now through that point in like the beginning of the year. And you can see we're on an upward tick. So we're heading northward, we're heading northward in declination. We almost get back to that 0 point, which if we got there, those rings would be absolutely edge on and would disappear. So the rings from our vantage point are going to be closing up, but it's not because of Saturn, it's because of our orbit. You can kind of consider that our orbit is taking us above and we're kind of looking down. And with those rings being tilted towards the south, that's going to make them look thinner. One more slide, I think.
That's very cool.
So I got this one backwards, I think, but here, give it one more click, Victor. There we go. So basically, depending on our perspective, you know, if we're looking from down on the rings from the northern hemisphere, they're going to look thinner. If we're on the southern side of it, they're going to look expanded. So that is what is going on. I highly recommend the link here. Wonderful article that really digs into this and explains it. Doesn't get too technical. But if you're a visual observer, try to take a look at Saturn now and watch it through till like early next year. And you'll see this opening and closing of the rings going on.
Cool.
And that is it for shallow skies.
Anybody got any questions for Jim? That was really cool, Jim. Thanks.
Yeah.
And by the way, we'll post these slides on the website, and when we PDF it, that link should work. Okay, Wayne, you're up with the news.
Okay, good evening and welcome to What's Up in Space. Your look at today's most exciting developments in astronomy and space science. I'm Wayne Baggett, and here are some top stories from the final frontier.
Yeah.
First up, a spacecraft is taking us closer to the sun than ever before. NASA's Parker Solar Probe has made history, capturing the closest ever images of the sun from just 3.8 million miles away. That's only about 1/25th of the distance from the Earth to the sun. The probe used its WHISPER instrument, that is short for Wide Field Imager for Solar Probe, to observe the solar wind and coronal mass ejections, or CMEs. CMEs are streams of charged particles, mostly protons and electrons, that can reach speeds of over 1 million miles per hour. The image on the right shows one of the pictures they took, and the orange line is actually indicating the wavefront, if you will, of the expanding coronal mass ejection. It's actually colliding with one that had been released previously. Understanding these solar outbursts is crucial, not just for science, but for safety. Space weather from the sun can affect Earth's electrical grids, satellites, and pose radiation hazards for astronauts in deep space. The probe's December 2024 flyby continues to provide groundbreaking insight into how the sun interacts with the solar system and could help us predict solar storms before they strike. And there's more info at the link down at the bottom. Next.
Before I hit next, does anybody want to make the sound effect when the thing's turning around? When the
Meanwhile, far beyond Pluto, NASA's New Horizons spacecraft is helping us learn how to navigate in interstellar space. Now over 47 astronomical units from Earth, that's more than 4.3 billion miles away, New Horizons recently tested a stellar navigation technique that uses the parallax of nearby stars. By capturing simultaneous images of Proxima Centauri and Wolf 359 from both Earth and the spacecraft, scientists were able to triangulate New Horizons' position in space, accurate to about 0.4 astronomical units, or roughly 37 million miles. That might sound like a wide margin, but in the context of interstellar distances, it's a major step toward autonomous deep space navigation, the kind we'll need for future missions that go beyond our solar system. The images at right show images of Proxima Centauri obtained. The left one is from Earth, and the right one is from New Horizons. And you can see that the star Proxima Centauri has moved relative to the background stars. In fact, it moved about 32 arc seconds, whereas if you just do parallax based from Earth using the Earth's orbit, you only get less than 1 arc second of parallax. So it was a relatively easy observation and obvious when you look at the images. So while these aren't research grade parallaxes, the results show that even modest telescopes like the LORRI camera can guide spacecraft far from Earth simply by using the stars themselves. And again, more info at that link in the bottom.
And for anybody, and for anybody that's a newbie in the room or online, parallax is basically if you put your thumb in front of your face and then switch, open and close one eye and the other, your thumb appears to move. That's what's happening here. The nearby stars move relative to the background stars.
And finally, a celebration is in order. The James Webb Space Telescope is now marking 3 years of space science operations. After launching in late 2021 and undergoing 6 months of commissioning, JWST began its science mission in July 2022. Since then, it's delivered stunning views of the cosmos, and its latest release is no exception. And that's the image shown on the right, which is of the Cat's Paw Nebula taken by the NIRCam. So to mark the occasion, NASA shared a spectacular NIRCam image of the Cat's Paw Nebula, a star-forming region teeming with young, massive stars that are carving out bubble-like voids in clouds of gas and dust. It's as beautifully as it is scientifically rich, since it's a star-forming region. JWST-related research has yielded many major scientific surprises, from rewriting theories about early galaxies to peering into the atmospheres of distant exoplanets. And you can explore 10 of those major scientific surprises at that website at the bottom. And as we enter year 4 of the 5-year primary mission for JWST, scientists are just scratching the surface of what JWST can reveal. And that's it for this edition of What's Up in Space.
Thanks, Wayne. Thank you.
And in the interest of full disclosure, I did use ChatGPT to help me write what I just read to you.
Well, you must have proofread it because everything seemed right.
I did proofread it. Yes, you have to do that with ChatGPT for those of you who are tempted to do this.
I love how things look so different. I mean, I was looking at that. I didn't recognize it as the cat's paw until you said it, until I read it. I love how different that things look in the IR.
The ability to penetrate the dust is really critical, and one of the primary advantages to JWST and other infrared observatories.
Okay, so yeah, we got a question.
JWST might be celebrating its 3rd anniversary of observing, but I'd like to point out that a week from tomorrow is the 10th anniversary of HALO's first light.
Oh, there you go. Oh, nice.
So
a week
we've
from
come a long
tomorrow.
way in 10 years as a club and in outreach, so it's very cool.
Were you able to hear that online?
Yes, yes.
Awesome. 10 years of Halo. I had kind of forgotten that, although I know it.
It just came up when we were at the meeting, I was at meeting yesterday here.
Wow, that's pretty cool.
Wow.
We should do something to commemorate it. Well, we'll see. Okay, well, we'll move on to the next section, which is members, Astro-Images. So if you're new, basically anybody in the club can send me a picture and we'll talk about it and go over it. And it ranges from, if Matthew, if you're still on, we have experienced astrophotographers, but we also have plenty of newbies who are just getting started, who share their images. And I mean, the club has, something like 400 members. So it's not just the gurus, although we got some good ones tonight. So sorry, go ahead, Phil.
Yeah, so this was taken on the 4th of July. And it was an unusual 4th of July because we had good skies during the day and we had good skies for fireworks later on. And the sun was celebrating along with us. There was just a lot of activity going on, and you can see it around the edge and you're looking at the chromosphere of the sun here. This was done with hydrogen alpha telescope. So, and I used SharpCap, and SharpCap has made some updates over the years and really doing well with solar now. So.
We should have like a little.
Oh, by the way, that up there on the right, those prominences coming up that row there, I did the math, that's about 250,000 miles, so you could put, 28 Earths edge to edge along the top of that.
28 Earths.
Yeah.
I think
So
we should
that
always,
is- and it's probably, it's hard to say how far it's coming off of the solar edge, because that one potentially could be coming from the backside.
yeah,
So it has the potential to be very huge.
wow,
And it's moving pretty quickly because of the approximately 93 million miles away. It's kind of like being in an airplane from 30,000 feet and looking down, nothing looks like it's moving, but it's moving very fast. And when you watch sometimes from between 10 minutes and 3 hours, you see the changes. You could visually watch them change.
yeah. I think maybe I'll mention something about it next time, but Kuiv, the lazy geek, the guy in Tokyo, he put out a video recently with this new this new mechanism for taking solar pictures. I think you'd find it interesting.
Yeah.
Right. I don't know if you've had a chance yet, but okay, thanks. And for anybody curious, this is how Phil makes the magic happen.
My solar observatory at home and having that gazebo, by the way, which is fantastic. It pops up and down in 5 minutes or less. But not only does it make it easier to see the screen and I can put everything in there, it also keeps me out of the sun when I'm out there for a long time. Because one thing is like with boaters and golfers, if you got to be careful not to give yourself skin cancer and things for sitting in the sun too long. So here I could stay outside of the sun, and I even have it set up so right at the edge there. So I put an eyepiece in and I do visual observing for a long time, and my head is pretty much covered up.
Cool. More tricks of the trade.
Yeah.
Gene, are you on?
Yep.
This is awesome.
Oh, you got the wrong name down there. Yeah, so this was kind of cool because they're different colors. The red part is SH2 129 called the Flying Bat Nebula, and the blue-green part is called the Squid Nebula. And what's cool about another cool thing about this is SH2 129 was discovered back in the 1950s, whereas the squid was discovered by an amateur astronomer in 2011. So people have been taking pictures of this thing for years and didn't even know there was a whole nother nebula there.
Huh.
Yeah, and like I said before, it's convenient that there are two different colors. The red's hydrogen alpha and the blue is oxygen 3.
That's awesome. That thing is so faint. How much do you remember how much integration time?
Yeah, it's down at the bottom there. It says 42 hours.
Oh, wow.
So, but it's a mosaic of 2 panels. So, divide by 2.
Yeah. Sorry, I copied the template that shouldn't say M5 there.
Yeah. Anyhow, so
Cool.
that's it.
That is gorgeous. Thank you. Okay, so I don't usually do this, but we didn't have too many, so I put in 2 of my own this time. So a few weeks ago, I went out to Western Maryland to do some dark sky observing and managed to, well, this one, I took some of the images that went into form this that night, and then some of them out in the Roadkill Cafe, which is Bortle 3 skies, a couple months before that. I think this is about 4 hours or a little more of light. And so it's M58 over here and M89. And these guys up here are whoops, how do I make that go? Yeah, I'm stealing my own thunder. Are these guys called are these the Siamese twins? I think these are the Siamese twins. The 2 that are behind Gene. So in any event, yeah, so this was about 4 hours of galaxies. And then this was less time. I definitely want to collect more light on this guy. This is NGC 5033. I love this distorted spiral due to some previous interactions that caused the arms to bend. And then, so you might say to yourself, oh, I can see more galaxies in this picture. There's one there. Here's one there. Here's one. Both of these are in Leo, I think. both of these images. So you might say, oh, there's another small galaxy, there's another, and here's one. But when you go and you do the inside, Pix Insight, it has the labeling thing for you. There are, if you go and zoom in on any of those pictures, you see a bunch of little smudges. These are my pictures with the labels on them. There are just a ton of galaxies that are, I don't even know how far, 800 million light years away, some of these tiny ones. So anyways, I thought that was kind of cool. So, and I've tried imaging these from local skies, and you won't get much. In order to get things like this, there's this very faint, there's this, where's my mouse? There's this faint jet. I really want to collect even more light to get this thing. Something went through and caused a gravitational streak of millions of stars that kind of go out. I don't know how many light years. So I want to go back and get even more light on this sky. But yeah, you can't get any of that from here. You got to get to Bortle 3 or lower skies. Okay, next we have Wayne.
So this is M13 taken from Alpha Ridge Park at the last two star parties, impromptu star parties. This is just less than 6 hours worth of total exposure time and LRGB.
Wow. And there's its little neighboring galaxy up.
Yep.
Oh, it's behind you. It's hiding behind you. Is that?
Yeah, there are not thousands or many, many galaxies in this image. Well, they are. Yeah, I just couldn't see them.
All right, thanks. And then we have a special as our last image for tonight. So Jim Johnson, who's here, in January, I think, he submitted this photo to us, and this was our image of the month for the club in January. This is the Dolphin Head Nebula, taken, I believe, from the Winter Star Party down in Florida. And he's published in Star and Sky Telescope. So we've got yeah, congrats.
Woohoo!
We've got a celebrity among us, and congratulations.
Thank you.
Is that the best you could do?
I'm gonna say yes. Just would like to say a few words about it. I talked about the technical details back in March or April, whenever it was shown here last. But that's the culmination of 5 years of work. That's integrating equipment and software and capture workflow and processing workflow, and behind that is help and encouragement and inspiration by the folks like Victor, Wayne Baggett. What big thing that Wayne taught me was you never finish a shot. You eventually abandon the project and move on. Ken Everhart in the back of the room, Gene Handler, folks like that have really inspired me. So that's how the picture got here. The other things that I added to that was, and again, the inspiration from the folks that I just mentioned, was to take the time to, first of all, get a great picture, but to get the camera rotation, to compose the shot to make it as good as it can be. And I think that's all I want to say about it.
It's really gorgeous.
It is.
So, yeah, congrats. And
Very well deserved.
Yeah.
Thank
you. And the feeling is mutual. I would have never started using generalized hyperbolic stretch if this wasn't for you.
Well, it was used on that.
Yeah. Okay, so that's all we have for tonight. So I want to thank everybody who came out, and it's really great to see so many people here. We have a few minutes before we have to vacate, so we can ask questions or chat if anybody wants to talk about Seestar or Joel. Yes.
This is still very preliminary, but I feel comfortable saying, because I wanted to get feedback from this room. Robinson Nature Center is going to be changing its hours with evening with availability